Okay, this says rock, paper, scissors is a hand game played. We all know how that works. Yada, yada, yada. Here's the table below. It says use this data to evaluate whether players choose between these three options randomly or if certain options are favored above others. So if they're chosen randomly, we would assume that they would all occur 1/3 of the time. If there's three choices and it was truly random, you would throw rock 1/3 of the time, paper 1/3 of the time, and scissors 1/3 of the time. So it says the distribution is uniform. That's what we're saying here. They're all the same. And then by our data, we're trying to show the opposite, or that they're not uniform. So that's going to be our first choice. We would think if it's uniform, they're all 1/3, they're all equally likely. So what we're going to do is we're going to put our data, the expected values, into L2 and our observed values into L1. So I'm going to pause the video and put that in my calculator real quick. Okay, so first thing I did was added all these numbers up. These numbers add up to 99. So if they were uniformly distributed, I would expect that 33, you would throw a rock 33 times, paper 33 times, and scissors 33 times. So I put the observed numbers into L1 and the expected numbers into L2. So now after I have that information input, I'm going to go to stat, I'm going to go over the tests, and I'm going to go to the chi-squared goodness of fit test. Okay, it's near the bottom, so you can scroll up and do it that way. But the observed list is L1, the expected list is L2. Now, how many degrees of freedom are there? Well, if there's three categories or three things we're choosing from, the degrees of freedom are going to be one less than that. K minus 1, K being the number of categories. So then we'll change degrees of freedom to 2. Go ahead and calculate. So we get everything we need. So our test statistic now in this case is chi-squared. This is going to be 7.515 or 7.52. Degrees of freedom is 2. P-value is 0.02334 or 0.0233. It says discuss the conclusion of the test. If it's not given, which I don't think it is, we assume alpha is 0.05. Our p-value is lower than alpha, so we reject HO. So we want to accept the alternative. So the distribution is not uniform. So the data provides sufficient evidence to claim that rock, paper, and scissors are not chosen equally as often as one another. That's what we just proved. They're chosen at some different probability.